If you've been watching the wildly fast-paced world of modern AI lately, let's be honest, you've probably felt at least a little overwhelmed at some point. I mean, everywhere we look, there's a brand new framework dropping, another massive language model, or just a wall of impenetrable jargon. It can literally feel like standing at the base of this massive, sheer cliff face, totally clueless on where to even place your hands first. But hey, that's exactly why we're doing this explainer. We're going to unpack the exact step-by-step path from absolute beginner to advanced AI engineer together. We're going to make this whole complex ecosystem structured, totally clear, and most importantly, accessible. Okay, let's dive right into this. Think of the AI engineer journey as mapping out a route up a massive mountain. Instead of just a chaotic jumble of tech buzzwords, it's actually a really strict 20-step progression. It winds all the way from the trailhead down at the absolute bottom left, right up to the flag planted at the snowy peak. We're going to climb this mountain together today, step by step. And as you'll see, every single concept builds the absolute critical foundation for the next. So to keep us from getting altitude sickness, we'll break this climb into 5 distinct phases: scaling the AI mountain, packing our gear at base camp, the ascent into machine learning, reaching the summit of advanced AI, and finally, engineering tomorrow's future. All right, phase 1, scaling the AI mountain. Before we take even a single step up that trail, we really have to nail down the overarching central theory governing this entire journey. And it's this: true AI engineering is not about jumping straight to the flashiest new tech. It is entirely about a strict progression of foundational logic. You absolutely must build foundational logic before deploying complex neural networks. Why? Well, because underneath the hood, AI isn't magic, right? It's basically just advanced matrix multiplication and calculus. So skipping that foundational math to instantly try and build the next ChatGPT, it's literally like trying to scale Everest in a t-shirt with no ropes. You won't be able to debug your models, and honestly, they just won't work. Mastering this strict sequence, really understanding the why before the how, that is the actual, somewhat unglamorous secret to long-term success. Moving right along to phase 2. Basecamp, foundations, and data. This right here is where we pack our technical gear. Before we can tackle the really steep climb, we need our core tools and raw materials to survive. So, the journey kicks off at steps 1 and 2 with Python fundamentals. Python is the lingua franca of AI. It's the universal tool you're going to use for pretty much everything. Once you've got that syntax locked in, step 3 brings in data structures and algorithms. You've got to know how to write code that actually optimizes and scales. But step 4? That is arguably the most critical checkpoint of all of Basecamp: statistics and mathematics. Remember that central theory we just talked about? AI is math. You absolutely need linear algebra, calculus, and probability because they form the literal underlying logic for the models we're building later. If you skip the math, you're really just memorizing code without having any clue what the machine is actually thinking. Next up, we hit the data-heavy side of Basecamp, which covers steps 5 through 8. In step 5, we use tools like NumPy and Pandas to really inspect and analyze our raw data. Then step 6 is data visualization, learning how to take spreadsheets full of boring numbers and turn them into compelling visual stories. Step 7 covers SQL and databases because, well, you have to know how to store and query the massive amounts of data that AI runs on. And then step 8, data cleaning and pre-processing. Listen, this is the unglamorous secret of the entire industry. Data scientists famously spend something like 80% of their time just cleaning up messy data. But it's totally vital. The golden rule in AI is garbage in, garbage out. Feed an AI messy, incorrect data, and you're going to get messy, incorrect answers. You have to learn to clean and manipulate your data before you even think about touching a single machine learning algorithm. So picture this. We have all this beautifully cleaned, well-structured data. We know how to code, we totally understand the underlying math, which leads us to a really provocative question. How do we actually move from just simply storing and visualizing all this data to actively predicting with it? How do we flip that switch from a static database into an intelligent learning system? That brings us perfectly to phase 3, the ascent into machine learning. We are officially leaving Basecamp now, and you can feel the trail getting steeper. This is where the core mechanics of machine prediction actually begin, putting all that strict logic and perfectly clean data to work. And I want you to notice the massive evolutionary leap happening right here. At step 10, we're diving into classical machine learning algorithms. These are the roots of intelligence, things like decision trees and linear regression. It's where you learn how algorithms can generalize information to make simple predictions. But then, right after that,
Bam! At step 11, we level up to deep learning basics. We make this huge transition from classical statistics into concepts totally inspired by the human brain. Neurons, hidden layers, complex pattern recognition. It's a massive leap in capability, but again, it is entirely built on the math from step 4 and the ML fundamentals from step 10.
And to actually make those incredible deep learning concepts a reality, we hit step 12, PyTorch and TensorFlow. You can study the theory of a neural network all day long, but step 12 provides the tangible, real-world Python frameworks you actually need to build, train, and optimize those deep learning layers on your own machine. And notice how this directly connects all the way back to those Python foundations we laid at step 1. It's giving us the heavy machinery for the rest of our ascent.
Welcome to Phase 4, the Summit of Advanced AI.
With our deep learning models built and trained, we have finally arrived at the summit. The air is definitely getting thin up here, and the concepts become incredibly advanced and highly, highly specialized. I mean, this is the stuff driving today's biggest tech headlines. Up here, we actually start giving our machines specific, almost human-like senses. Step 13 is computer vision, literally teaching machines to see and interpret images and video. Step 14 is natural language processing, or NLP. Text in, inside out, teaching the machine all the wild complexities of human grammar and context. And then at step 15, we tap into Hugging Face and transformers. Because instead of trying to train massive models from scratch every single time, we learn to leverage pre-trained power. We take these incredibly smart, existing models and adapt them perfectly to our specific needs. And that brings us right to step 16, where it's time to bust some of the biggest jargon in the tech world today. LLMs, or large language models. These are just massive systems designed to deeply understand, generate, and scale human language. Now, this isn't some magic invention that appeared out of nowhere. LLMs are really just the massive, scaled-up evolution of the exact natural language processing foundations we laid down just 2 steps prior. But here's the thing. LLMs have a major flaw. They can hallucinate. They'll just make things up if they don't know the answer. Enter step 17, RAG, which stands for Retrieval Augmented Generation. And this brilliantly illustrates our central theory of progression. RAG is a clever technique that forces the language model to retrieve facts from your specific, trusted database before it's allowed to generate an answer. The result? Grounded, smarter, totally factual outputs. But think about the mechanics there for a second. To make RAG work in step 17, you desperately need the SQL database skills from step 7 and the data cleaning skills from step 8. The summit relies directly on Basecamp. Next up is step 18, AI agents and tool calling. We are looking at a massive paradigm shift here, folks. Up until now, models kind of just sat there and answered your questions. But at step 18, they evolve into independent agents that can actually act and adapt. We're talking about models that can browse the web, write and execute their own Python code, or even trigger external APIs to solve complex problems totally on their own. This level of autonomy is a massive milestone. And let's be real, it's absolutely only possible because of the incredibly rigid logic we established over the previous 17 steps. And our final stretch, Phase 5, Engineering Tomorrow's Future. We are mere inches from the top. Now it's time to take everything we've meticulously built in our local dev environment and actually share it with the world. This final ascent is steps 19 and 20. Step 19 is MLOps and model deployment. This is where you learn the hardcore, rigorous engineering practices required to take a model out of the experimental lab and package it securely for real-world production. And finally, step 20, production AI systems. This is it. You deploy the agent, you set up dashboards to constantly monitor its health and accuracy, and you ensure the server architecture can seamlessly scale whether you've got 10 users or 10 million. You aren't just experimenting anymore. You are running a live, highly intelligent product. And with that, we've reached the peak. There's a quote from our source material today that I think just perfectly sums up this entire journey. Every step you learn today builds the future you'll engineer tomorrow. I love that. It perfectly encapsulates the central theory we've been exploring this whole time. It absolutely proves you cannot just leap straight to the top. But if you respect the progression, if you put in the time to master the math, the data, and those foundational algorithms, there is literally no limit to what you can build. So, looking back down that massive mountain we just climbed, which foundational step are you going to tackle first to start engineering your own future?